The purpose of this video is to make a chord diagram in RStudio. The intention for this visualization is to eventually use it in a future project. So I wanted to use it just kind of some made up data, as you will, to represent what I want my future chord diagram to look like. So in this case, I'm using job titles and I am using competencies as my variables. So I'm just going to get into it. I've already installed Circleize and ReadXL packages in my R environment, so I'm going to go ahead and load those with the library function, which loads Circleize and ReadXL. I need ReadXL to read my data file, and I'm going to save it to an object called df, and I'm going to use this little arrow to push it there. So I'm just going to run that. Now I have a data frame with 6 observations of 6 variables. The names of my variables are these job titles, and the meaning of the data just represents, it doesn't really represent anything because I made it up, but maybe so here they have no meaning, unfortunately, so I guess that's a bad thing to say about them. Here are my next, then the next thing I'm going to do is I'm going to make this data frame, this tibble, it's actually a tibble, into a matrix, because I was unable to run one of these functions on it as a tibble. Actually it was this row names function. So the next thing I want to do is, so when you look at the data, it is just these columns, and the row names right now are 1, 2, 3, 4, 5, 6, technically. So I want to change that. I am going to change the row names using the row names function, and pass it to the argument of my data. And I am just going to feed it a vector of these different competencies. So I have data analysis. Well, I have some other ones. I'm just going to run this code, and then now when we look at the data frame, I have this new column that has renamed the rows to these competencies. So the idea here is similar to and this is just now a matrix, and a value in here would represent a relationship between these two. So this could be a correlation matrix or a Markov matrix, but you just have values in here and they would represent something. And so this could represent, for an example, how much time out of 100%, how much percent of OD practitioners' role uses data analysis and visualization. That's just an example of kind of how of what it could look like, what the data should mean. And then using the chord diagram function of the Circleize package, I'm just going to run the chord diagram on my data frame, on my data. And it pops up this visualization, which is not very useful. So you can barely see down here on the bottom that we have the competencies, and then up here are the job titles. This does not look very good at all, and it is very difficult to read, even when you make it bigger. I'm not going to make it bigger right now. Just trust me, I've already done that. So part of the, I was going to say, like, part of the beginning of this was getting the data together to try to figure out what it should look like, but you see that actually didn't end up being very difficult. But I'm going to go ahead and use this circos.clear function, which is also part of the circleize function. And this resets my plot area back. It just, before it reverts it back to its default so I can make another plot. If I didn't, it would just build on top of this one visualization, which I'm getting ready to do that next. So like I said, I didn't find this very useful. Now, I'm going to skip this part right here just so I can show a difference in some chord diagrams. So now I'm going to use the chord diagram function, but I'm going to pass it through many arguments. So I'm still using the same data, that hasn't changed. Transparency, the transparency argument, which takes an argument between, like 1 and 199%, I'm assuming. And it changes how potent, like how dark or light, it affects the transparency of these chords. I'm using the directional argument here, and this just is telling the function that I want these paths to be directional, that they are bidirectional, but I want to show from this bottom half, from the competencies to the different positions. The direction type, I'm going to use arrows. The annotation track is this outside perimeter, and it can take 3 arguments. It can have a name, it can have a grid, or it can have the axes. And in the default, it has all of those. So this is the name, this is the grid, and then the axes are these little points on the grid, the little tick marks, so to speak. And so I just want the grid. For the annotation track height, this changes the difference between the grid, or it just changes this like grid height right here. The link.arr.type argument I'm using is a big arrow. I tried out a couple of other functions for this, but it really only like allowed me to change like a big arrow or a triangle arrow, which put a black line. It wasn't very nice. So I like this one better. So the link sort just sorts these links. If you can kind of see these in the arrangement. And then the link largest on top, I'm equaling that to true. And that puts the largest link on the top of each axis, which is, or of each subgroup within these. So if you can see it more clearly right here, that the largest link is on the top. And then for scale, I want this to be true, because it will make each link of these the same size. So, and they're really still not the same size. Oh, wait, right here, they're not the same size, if you can see. Like this one is smaller than this one, but it's supposed to make them the same size. If I equal, so before it was by default on false. So now I'm going to make sure I did run my circles clear, and I'm going to run this new chord diagram. So now I have something that looks a little bit different. You see that I have widened this grid. I've removed the names and the axes, but I've widened the grid, which is this outside ring right here. And I'll just show you for difference. Widen the grid. Now I have these directional arrows. You see these? On the top. That is going from the bottom part to the top. You see that? It does have this thick wide space right here, which is strange. And you see that all of these segments look equal. So they're just kind of like filling that in, making it more visually pleasing. Okay, cool. So the next thing that I'm going to do is, and see now I'm not going to go clear my, my plot. I'm going to add to the region. So here I'm going to change the text and the axis tick marks, which were these little points in here. I mean, I don't have to use them at all, but they can be helpful. So to do that, I'm going to use the circus.track plot region function, which takes in a whole bunch of arguments. And basically, it has a track index, which is just equal to 1, which means that the track has already been made. And if it was set to null or was not used at all, then it would indicate a new track being made. So that argument should be run like together with a chord diagram. Then there is this BG dot border that is equal to NA. I'm not using this function. It does indicate specific colors for the track. And then the panel.fun article equals function to X, Y. And by default, all of this information is null. But because I want to customize this, I am going to change it up. And so this is just creating a function. So first I'm setting the xlim and the sector.index arguments to get cell metadata of xlim. And then, so I'm telling it to get the cell metadata for these two variables, for these two arguments. Then I'm adding text using the circus text argument, and the X is the mean of the cell metadata. And what that does is puts them in the center. And then then the Y text is going to be at 6. Now I have played around with this a little bit, and I ended on 6, but once I run it, I'll explain exactly where it's working, but it's where it puts the text in relation to this track. The labels that I want are going to be the sector index metadata, which is why I wanted to go get this. So this xlim is the numerical values, and the sector index is the name. So we're going to go get use those for the labels. The way that I want the text to face is going to be clockwise. So that's what the facing argument is. It can also be, it has a clockwise, counterclockwise, curved, which puts the text curved around the circle, which I really liked, but the names didn't fit. And then nice facing is going to be equal to true. Nice facing makes the text easier to read for humans. I decided not to use this adjust argument. It made very little change in where the adjustment was to the text. And then this is the size of the text, and just changing it to 0.8 of its original size. So, well, I have to go through the rest of the text before I tell you what it is. Then the circus axis function is going to define the little tick marks that are on each side, each of these little segments. So the height of it, they're going to be on the top, which I don't know why it uses the H argument, because you can also make them be on the inside or the bottom. And then just the major, there's a difference between major ticks and minor ticks. The major ticks are the big ones, and so I'm just leaving that at default. And the minor ticks are the little ticks that are going to be in between each major tick. And I can define this to any number, and I want there to be 2 ticks. And I believe that if I put like more, I've used like 5, but it made it really scale really big. So for more data though, I think that it could be really useful if you wanted to have a lot of words and stuff going around this. I think that that would really be helpful. The size of these labels, I want to be half the size of their original. And then I'm not going to use nice facing labels for this. That would put them opposite, like upside down, right side up here. So I'll show you what I mean. So this is all one argument, because everything in here is inside this function. So I will run this, and So you see I have all of these errors down here for one thing. And this is just something, I just wanted to run this so I could show you. They're saying that I have a point out of the plotting region. Oh, there's something else here that I didn't show. This. Well, I'm just going to keep going because, so, okay, now I have, what I have here, this track index. You see these? Now they're in decimal points. Okay, but let me talk about this. So I think that it still looks really fuzzy, and you see how some of these are overlapping, and it is it's still like really clunky. I use the argument to make these indicate like what percentage, which is why I was talking about, the data was kind of meaningless. But in the future, I want to make it so that the width and direction of the arrows represents how much of the job role this competency is used. And so you see this is 100%. So I think that that's going to be really useful in the future. On my next steps, I will keep y'all updated. But look, this is hardcore not working for me. So I'm going to clear that off, and I'm going to show you one more function while I'm here. So I'm going to run my clear circos.clear, and we're going to change this. I'm going to change this. What I'm going to do is I'm going to change the parameters using the circos.par. So one thing that you can do with using this is changing the degree that this starts on. So like I could use 90 degrees here, and it would it would be the halves. It would just rotate 90 degrees. It would be like half and half. I decided not to use that because I'm still looking at the functionality of this, the way that this is oriented, this orientation. So one thing that I want to change is the gap degree. And that is the space that happens between all of the tracks. The margin, I'm going to change this, and this is just going to move the margins of this track region a bit. Next, I'm going to change this points overflow warning to false. That way I don't get all of these notifications, these arrows. And then I'm going to change the parameters of the margins, and this argument right here just changes the parameters of these margins that are outside of the inner circle visualization. So let's start. I'm going to start with these. Then I'm going to run the same chord diagram. So now we see something that's a little bit different. Notice that these gaps right here on the sides have closed up because I changed the gap degree and the track margins so that they are more equal. Also, the arrows go a little bit closer to the track margin. Then I'm going to add in my text. And now do you see how the text and lines and little tick marks are much more easy to read? And I'm just going to flip back. See, maybe to me they're easier to read. So there we have a chord diagram. Now, one of the things that I did notice about this, and that I really struggled with setting this Y point right here, which moves these guys, these names in and out, because depending on where I move my visualization, it changes where they are. So if I make it smaller, then they're going to start overlapping more. But if I make it bigger, hold on, see then it moves the text in. So this was a little bit challenging for me. I don't know if it needs to be formally published, and then when I exported it, also, or saved and exported it, it kept the exact same layout that I had in this plot area. So I'm wondering if you have to use publish in order to publish it and make it useful on any device that you're looking at it on. But anyway, that's my tutorial and my experience with the chord plot using Circleize. So thank you for watching, and I'm going to keep working on this. Cheers.